Okay, having a look at the solutions to the 2022 paper 1 tech-free question. So I have done the multi-choice questions for this, and I got a request for to have a walk through these answers to the second section of that paper. So to start with, we have a ln 2x equals 5. So with this type of question, you need to know how to rearrange that. So we can write that as e to the 5 is equal to 2x. Once we've done that, we're dividing by 2, so we get our answer of a half e to the 5, or we can write e to the 5 over 2. For the second question there, for part B, we've got a classic log question where we've got subtraction there, so we know to divide. So we can write our 4x plus 16 over x squared minus 2 equals 1. And then we're using that knowledge that if we have log 4, that will be equal to 1, so that this section here must be equal to 4. So we can write 4x plus 16 over x squared minus 2 equals 4. We can take that x squared minus 2 over to the other side, then expand that out to 4x squared minus 8. We can then bring all the terms over to that side so we have an equals 0, so that we can then factorize and use the null factor law to solve. So we can simplify that to 4x squared minus 4x minus 24. Take out that common factor of 4, we're left with a simple quadratic which we can factorize as x minus 3, x plus 2, with our 4 out the front, and then using our null factor law, say that the x must be equal to 3 or negative 2. Remember to always go back to that log question once we get our answers and just check you don't get a negative in either of those brackets, because if you do, you'll have to discount that option. So when we put in the 3, we've got 4 times 3 is 12 plus 16, that's fine. 3 squared is 9, take away 2 is 7, that's fine. Then if we put in our negative 2, 4 times negative 2 is negative 8 plus 16, that's still positive. Negative 2 squared is going to be 4, take away 2 is 2. So that's fine, both options work for that one. Then we get to question 12. Now question 12 has a little bit of a trick to it that you need to recognise what to do. So we've got the probability that a debating team wins a debate, and the fact they've got a debate leads us to know it's just one scenario we're looking at. Can be modelled by Bernoulli, so that means we've either got success or failure. And we've been given the probability of winning the debate is 4/5. That way we can set up our little table where we've got x, 0, 1, p of 1/5, 4/5. I was fiddling around with a little bit of this at the top before I realised I needed to use this method. So when I do my mean, I'm doing the 0 times the 1/5 plus the 1 times 4/5, which is going to give me the 4/5 there. Then when we do the variance, I use the method of squaring that x value times the probability, squaring the next one times the probability. Some may use a different rule for that. So when I do that, I get 0 squared times 1/5, still going to be 0. 1 squared times 4/5 is going to be 4/5. So I have my 4/5 there, and I'm squaring my mean. So that gives me the 16 on 25. If I changed that 4/5 to over 25, I get 20 over 25 minus 16 over 25, which gives me my 4 over 25. So making sure you're familiar with your fractions for the tech-free paper. Then when we do our standard deviation, it's just the square root of the variance. So we've got to do the square root of our 4 on 25. So the square root of 4 is 2, and the square root of 25 is 5. Having a look at question 13, we have got our derivative of 3e to the 2x plus 1. So a very standard derivative of an e to the x. It's only worth the 1 mark, nice and easy. So we're doing the derivative of the 2x plus 1 and bringing that down the front. So we get 6. So we've got our 3 times 2 is 6, e to the 2x plus 1. In the second one, we're doing a quotient rule, because we've got that our g of x is ln of x over x, and we want the g dash e. So I've set it up saying my u over v, where my u is equal to ln x, v is equal to x, u dash is 1 on x, v dash is 1. Then I can put it into my quotient rule. Then I get 1 over x times x minus 1 times ln x on x squared. I'll simplify that and get my 1 minus ln x on x squared. Then we're wanting the g of e. So now I'm going to tackle that part of it and substitute in an e wherever I see the x. So I've got 1 minus ln of e over e squared. You need to remember that ln of e is 1. So we can do 1 take 1 is 0 over e squared, which is just 0. Then we've got a second derivative that we want to work out, but we have to use our product rule. So we're using that product rule twice to get the second derivative. So for the first time, we've got x sine x, so our u is x, our v is sine x, our u dash is 1, and our v dash is cos x, so we've got u dash v plus v dash u. So we've got 1 sine x plus cos x times x, which gives us sine x plus x cos x. So then when we do the derivative again, our sine x can go straight to the cos x, but our x cos x we have to use our product rule for. So we've got our u is equal to x, v is equal to cos x, u dash is 1, and v dash is negative sine x. So then we're putting that into our u dash v plus v dash u. So we've got 1 times cos x plus negative sine x times x. So we end up with cos x plus cos x, take away x sine x. We can bring those two cos x together, and we get 2 cos x minus x sine x. So question 14, we've got the rate that water fills an empty vessel. The empty is a key part here. Is given by dv on dt is 0.25 to the 0.25 t between 0 and 8 ln 6. We want to determine the function that represents the volume. So we need to integrate our derivative to get our volume. So when we do our integration, we're dividing by whatever that derivative is up here. So we're dividing by 0.25. 0.25 divided by 0.25 just leaves us with e to the 0.25t plus c. Then we're using that empty part to go 0 is equal to e to the 0.25 times 0 plus c. So if we've got 0 is equal to e to 0 plus c, we know that e to 0 is 1, so our c must be negative 1. And so over here we should have a negative 1 there. And then coming down into the second part, the vessel is full when t equals 8 ln 6. So find the volume to the nearest litre that the vessel can hold full. So we've got that our volume is equal to e to the 0.25t minus 1. We're putting into that the 8 ln 6 minus 1, so that leaves us with 2 ln 6, which we can change to ln of 6 squared, which is ln of 36. Once we've got that, e to the ln of 36 is just 36. So then we've got 36 take away 1 is going to give us 35. And then we've got a table then that shows the approximate rate the water flows into the vessel at certain times. So now we're using the trapezoidal rule. Now if I had to make a prediction, trapezoidal rule is the one that I've seen on all the multi-choice papers. I'm seeing it again now. Trapezoidal rule would be one I'm predicting that you are going to see a question of. So our trapezoidal rule, I like to simplify it here, where we've got width over 2 plus the ends, outside of ends plus 2 times the middles. So that's how I like to, I sometimes write an E there even instead of ends to try and simplify it. So basically we've got whatever the width of our parts are. So here we've got 0, 1, 2, 3, 4, that's going up in ones. So we've got 1 over 2 outside the bracket. Then we've got 0.25 and 0.53 are our ends. And then we've got 2 times the middle, so the 0.32 plus 0.41. As you can see, I've had to do a little bit of decimal work over the side there to work those ones out, but they are fairly straightforward, and you end up with the 1.12 litres. Question 15. So we've got the derivative is given by e to the x outside of x minus 4. Determine the interval in which the graph of f of x is both decreasing and concave up. So that's leading us to go, if we've got, that we're going to look at the second derivative. So we're going to have to do the derivative of that. I've simplified a little bit up here and written my u, my v dash, my u dash, put them together, and I get my e to the x outside of x minus 4 plus e to the x equals 0, because that's where I know that I'm looking for that point of inflection, and so that gives me 0 or x equals 3. I then investigate that a little bit further to see what's happening, and I can see that it is again at 4 when I'm checking in my first derivative, so then I can know that it is between 3 and 4 there that I'm looking for. So I was kind of looking either side. Then we've got some graphs given to us. Now I've seen a similar one to this in another paper, and so the process that I went through when I'm looking at this type of one, we're told that we've got the first and second derivatives, and we want to explain what the original function was. So obviously I went along and found, like on my solid line, where one cycle was. I identified where that was. and I've got a bit of working down the side here, period of 16 pi on 2, to work out what my b would be of 3 on 2. I also said, so this is my one here, I've said it's a reflected sine curve, and I've looked at my amplitude, so I can see that the amplitude is 3 to -3 for that one, so I've got -3 sine 3 on 2x that I've come up with for that solid line one. For the dotted line, I can see that it's going to 4.5 and -4.5, so my amplitude is -4.5. I've got that same period, so I've noticed that it's the same period, so I'll have the same b. And so then I've kind of gone, okay, well, which way am I going? I know that cos goes to sine, so I'm thinking that must be my second derivative, so I'm going backwards from this one. And so that gets me to my 2 cos 3 on 2x to get back to the original. So that's kind of the process that I went through to follow that, to work out which bits I wanted for that. Question 17, determining the value of b when we're given these two pieces of information. So obviously we're going to solve simultaneously. We've got the function 3x squared, so obviously the integral of that is x cubed. So between a and b it's 117, and a and b minus 1 it's 56, so I've subbed that in. So b cubed minus a cubed is 117, b minus 1 cubed minus a cubed is 56. So I lined them up to do an elimination one, so I could cancel out the a cubed. That left me with b cubed minus b minus 1 cubed is equal to 117 minus 56. Then obviously I need to expand this out and simplify, which got me to -3b squared plus 3b minus 1 equals 61. I'm then going to bring that 61 over, which gives me this equation here, 3b squared plus 3b plus 60 equals 0, which I can then factorise. So I've taken out a factor of -3. Then I've factorised this part of it using my ACB method. Number that multiplies to get -20 but adds to get -1 is our -5 and 4. So then we can solve that using the null factor law to say that b is equal to 5 or -4. But because we've been told that b is greater than 1 back up in the original statement, that means that it has to be the b equals 5. I then went on to find a and realised I didn't need to do that because I only wanted b. But obviously you can solve a by subbing that back into the original. Then I've got question 18. We've got a percentile is a measure in statistics showing the value below which a given percentage of observations occur. The continuous random variable x has the probability density function of this here. And so we want to determine the 36th percentile. So for 36th percentile, we need the 0.36 there. We're going between 1 and a, so we can sub that in. Obviously, we had to do the integral of 2x minus 2, which is just your x squared minus 2x. We're going to do sub in the a, subtract when the 1 is in. So simplifying that when that's expanded out. Bring across, which I felt was a bit mean, bringing the decimals in. Bringing that decimal across here and getting 0.64, which then forces you to use quadratic formula. Also a bit mean for decimals, I felt. And so looking at that then, writing down the ABC, plugging that in, and so fortunately we get to a point where we have 1.44, which we know like we should recognise 144 as a square number. So if it's 1.44, then 1.2 is the square root of that. And then you're doing 2 plus 1.2 over 2 or 2 minus 1.2 over 2. And again, please be mindful of this. Do not write outside this box, which I did not adhere to when doing these solutions. And then that leaves the last question, which you can look up the solutions for. It's quite long, and for the sake of the length of this video, I would direct you to have a look at those QCAA solutions for that. Hopefully that gives you a bit of insight into how to work through those questions.